In this lecture, we will learn about the Caesar cipher and how to implement it in Python. This cipher is actually named after the Roman Emperor Julius Caesar, who used this technique to write messages in code that were passed to his people. If an enemy intercepted a message, they would not be able to read it since it was written in a secret code. Of course, this was before the time of computers, but he did it with just paper and ink. With the Caesar cipher, each letter is replaced by a letter some fixed number of positions down in the alphabet. For example, let's pretend that the variable position that we choose is 2. Each letter in the original message gets replaced with its corresponding letter 2 spots down in the alphabet. So a message of A, B, C, D would be translated into C, D, E, F. 2 letters down from A is C, so any spot that A appears in the original message, we put a C. Then 2 letters down from B is D, so anywhere a B is in the original message, we put a D. So on and so forth. Let's write the code to encrypt a message using the Caesar cipher. We will start out with a variable named message set equal to the string ABCD. Now we will create a function named encrypt. This function will take in 2 parameters, text and amount. Inside of this function we will have a variable named result that we initialize to an empty string. Then we will have a for loop, for I in range len text. Inside of this for loop we will set char equal to text at index I. Then we will add the new encrypted version of the character to the result variable. This code might look confusing, but all it is doing is adding the amount we give it and ensuring that we stay in the range of the lowercase Unicode characters. Finally, outside of the for loop, we will return result. Let's use Python's print function to print out the result of a call to the encrypt function and pass in message as the first argument and 2 as the second argument. When we run the code, you will notice that the message ABCD was successfully encrypted into the cipher text CDEF. Let's take a look at how to hack the Caesar cipher using a brute force hacking algorithm. Hacking a Caesar cipher that uses the 26-letter alphabet is more straightforward than you might think. To start, I ran the encrypt function on the word secret. The cipher text for that is UGETGV. Oh, and by the way, for these functions to work, we assume that the message is one lowercase word with no spaces. I am doing this to keep it simple. In the real world, you might end up writing a program that encrypts different alphabets with many more than 26 lowercase letters. But this will give you your foundational knowledge for doing so. Then we will create a variable named letters and set it to a string containing each letter in the alphabet in sequence in lowercase. So this string becomes A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Now we need a for loop that will go through each key in the range length of letters. We will create a variable named translated and set it equal to an empty string. For each symbol in message, we will check if the symbol is in letters. If it is, we will set num equal to letters.findSymbol. Then we will set num equal to num minus key. After that, we will check if num is less than 0, so we will add the length of letters to num. Then we will append letters at index num to the translated string. Else we will add symbol to the translated string. Then we will print out the key and then the translated message. So what exactly is going on? Well, with a 26-letter alphabet, there are only 25 possible values that can be used to space out the letters. So this algorithm tries all 25 combinations and prints out their translations. One of them will come back as an English word, and the other 24 will look like garbled text. When we run the code, you should see that hacking key 2 successfully decrypted the cipher text, revealing the original message, secret. Great job! You just learned how to use the Caesar cipher to encrypt text, and then how to write a program that hacks the algorithm to decrypt the text. In the next lecture, we will learn about the ROT13 algorithm and how to implement it in Python.